matching stuff? It's like
That is quite possibly the worst worksheet ever. It was something that a teacher had from before, and I continue to refine it, but it's a great thing that if I'm walking you through it and pointing out, yeah, this is worded crappy and blah, 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 I'm not even going to look at it.
okay.
So you don't have to worry about that. It was something that I had from past years, but I'm trying to weed out some of the fat to allow us more time to focus on things, since we're kind of at times losing half days and losing this and losing that because of Google Meets and things like that, or whatever. So if you jump to this review, it's just review number 2. But before we do that, if you can give me any problems, and then I'll go through and do them in order. I've gotten requests for number 29 and 56, but that is it. So we're going to look at 29 and 56. Are there any other ones?
What is this on? The quiz?
This is review number 1.
Okay.
And then at the end of that, I'll just randomly or selectively, whatever, go through questions from review number 2.
Will you do?
Or quiz, whatever the quiz. So these are problems from review number 1. So what else?
40 and 47.
40 and 47.
Yeah.
Anybody else?
61.
61.
I went 28B. Wait, not 28B. 9.
Wait. 18.
Number 9.
Number 9?
Yes.
That's so different. What else? Anyone? So for right now, we're going to look at these. So viewers at home, if you don't have any questions on these, but you'd have questions on something else, we might have tackled it. Maybe scan to the end of 61, and then we'll, in the video, and then we might be looking at quiz 1 or review 2. All right? So here's review 1, which was on page, all right, so we're on, in the book, page 57, we're looking at number 9. Okay, so it says, where on the function above, which is off the screen right now, is the graph continuous? Okay, which is different than domain. Domain means f of whatever exists. So you're telling me where the function exists. Continuous is 2 other checks. Not only does it have to exist there, right? Function has to exist at those values, but the limit has to exist at those values, and they have to be the same. So this usually cuts down your domain a little bit more, a little further. Not always, but sometimes this is a little bit more refined, a little bit more selective than this. So let's go back up and look, and I'll walk you through what I would do for number 9, looking at this continuity. Now the first thing I'm going to look at, obviously, is just domain. I'm looking at this, and according to that, this parabola exists less than or equal to -1. And I know that that parabola does not have holes and VAs in it because polynomials don't have holes and VAs and weird stuff. So I know that if I'm talking about continuity, from -infinity all the way up to, but maybe not including -1, it is continuous, right? But what about at -1? Well, let's check continuity at -1. For something to be continuous at -1, the value has to exist at -1. F of -1 does exist because there's an equal sign, and you can plug it in and get an answer. The limit would have to exist. Well, from the left, I plug it in there and I get 6. From the right side of -1, I plug it in there and I also get 6. So the limit does exist. And they're equal because at equal, I also get 6. So at -1, it is continuous. So I do not have to break it here at -1. I can move right through -1 onto the next potential discontinuity. Well, as I'm moving past -1 now, all the way to 3, I'm along a what? Lines don't have holes in VAs. So it should be continuous all the way up to, but maybe or maybe not including the -3. So I check the 3, not -3, the +3. Well, let's check it. Does the value exist at 3? Yes, it does. At 3, the value is -2. Does the limit exist at 3? Well, from the left, I get 4 minus 6, which is -2. From the right, I get 12 minus 10, which is positive 2. So the limit doesn't exist. So even though the value existed, the limit didn't, and if the limit doesn't, then there's no way they're equal, right? So it is not continuous at 3. Are y'all with me on that? So I have to break it here at 3 because it is not continuous there. And you can put a union or a comma. AP normally puts commas. All right? But they don't care about unions. Unions even better. Just don't write a union like this. Okay? Bad union. Good union. Okay? Now, let's move past 3. According to this, between 3 and 5, a line exists. I don't have any issues with lines when it comes to continuity. They're nice and continuous, right? So, all the way moving through up to and maybe including 5, it would be continuous. But I know at 5 it's not continuous. Why? There's no f of 5. So I don't even have to check the limit there because there's no value there. One of the rules of continuity was broken, then I have to split it up here at 5. So I'm going to go from 3, I broke it at 3, and now I'm going to have to break it at 5. All right? So you can check the limit if you want, but it doesn't matter because there's nothing there. Now, this between 5 and 9, this exists. Well, what is this? This is one of these functions, right? Now, it just so happens that the vertical asymptote occurs in that interval, right? So this is a continuous function everywhere except at the VA. And the VA happens to be on that interval. Now, if this had been x minus 2, there's a VA at 2, but who cares? This graph doesn't show up where the VA is, right? This is only from 5 to 9. 2 would not have mattered. So don't go and break it at 2 because of that. But in this case, the 7 is in that interval, and that's the only place in question. I've got to break it at 7. Okay? Now, I move all the way through to 9. 9 is the next point of contention, right? Now, at 9, let's see. Does a value exist at 9? Yes, I plug a 9 in there, I get 2 on the bottom. Negative 20 over 2 is negative 10. All right? So the value exists. Does the limit exist? Well, from the left, it's negative 10. From the right, it's what? The log of negative 1, I can't log a negative number. Doesn't even exist. So the limit doesn't exist. So there's no way this thing's continuous at 9, so I have to break it at 9. Now here's where you have to be careful. A lot of times people put comma and then another 9 because that's the habit they've been in. But this graph, even though it says when it's greater than 9, I'm going to use this graph, it doesn't mean that 9's going to work, or 10's going to work, or 9.5's going to work. It just says, hey, when you're graphing to the right of 9, this graph shows up. But think about this graph. This graph has a shift at 10, right? You with me? And a log graph looks something like this. So even though I'm saying, hey, at 9, graph this, this graph doesn't have anything at 9, does it? In fact, it doesn't even show up until what? To the right side, right? To the east side of 10. So really, you're not even going to have a 9 in this. It's going to jump to what? To the 10 and head to infinity. And you don't have to check anywhere else because you know that a log graph heads to infinity, but it just does. It starts just to the other side of 10. Now, if you're looking at that going, that's brutal. You're right, it is. Would AP give you something this ugly? Probably not. Would I on a test give you something with logs and stuff like that in there? Probably not. But I want you to be better than just, it's like if you shoot at nothing, you're going to hit it every time, right? I mean, it's easy to not have goals. I try to make it harder on my tests. When you get to the AP test, you're going to go, ugh. Which is why 94 or 92, whatever percent of our kids pass and 75% make A's and B's. Fours and fives. So that's my goal, is to make you not just average. The nation can be average. Alabama can be below average. We are going to be way above average. And we usually are a solid point above the national average on the AP test, which is pretty remarkable, especially considering we make everybody take it. And not every school system does that. So nationally, people take it when they think they're going to pass. We take it regardless. So really, if with people who weren't going to pass or who felt really bad about it didn't have to take it in here, our scores would be even higher. Who wants to get smoked when they know they're going to get a 1 because they've done nothing? Nobody's spending their money on that, right? Oh, What did I just erase? Tell me what they were. I had a 56.
47 and a 61.
40 what?
7.
And a 61?
Yeah.
Okay, so that's number 9, and it's a great question. In the past that has been a question, but I doubt it would be this tricky. It might be, but I doubt it. Doesn't feel in my soul like it would probably have been that tricky. All right, let's jump to 29. And I will tell you, I will not ask a question about 29. 29 talks about the intermediate value theorem. I will briefly just tell you what that is if you're curious, and we will discuss that more this year. And I have no idea why it's on here. I mean, I kind of do, but it's whatever. So basically, this is the intermediate value theorem in real world explanation. All right? You're in a car at time 0, and you're going 20 miles an hour. Later, at time 10, you're going 100 miles an hour. Between time 0 and time 10, have you ever hit 60 miles an hour?
Yes.
Yeah? What do you mean, most likely?
You have to have.
The only way you wouldn't is if you could somehow, like, hyperspace and jump, but you can't, right? We know in our world, acceleration happens continuously. You punch the gas and it's like 20, 30, 40, 50, 60, 70, 80, 90, 100. You go through every mile per hour, don't you? Every single one. Because it's a continuous function. You can't just go 100. I mean, you just can't do that. Well, that's because acceleration in our world is a continuous function. Okay? So the intermediate value theorem says, hey, if you have a continuous function on a certain domain, like from 4 to 10, then I have to go through every possible y value. So like at time 4, if I'm 18 miles an hour, and then at time 10, I'm 2 miles an hour, at some point I have to go through every single y value between 18 and 2. That's what the intermediate value theorem says. So it says, number 1, which of the following are true? There is a y that equals 30 that does not have a solution. That basically means this. Check it out. I know it's weird wording, but you will get used to it over time. F of 4 is up here at 18. F of 10 is down here at 2. Okay? So, this says y equals 30, which would be like the line y equals 30, does not have a solution on that interval. Is that true? At first glance, people think, yeah, that's true because I'm just going to go from here to here. But not necessarily. I could accelerate up to 30 and then back down, couldn't I? Are you following me? So is it guaranteed that this won't have a solution? No, it could. And it says, which are true. Well, that could be true. What about this? F of 16 has a solution. Now, that's guaranteed. I know that's true because look at this. Right here, I have to get from here to here, at least at some point, go through that at least once. Right? And that says f of 0 has a solution. All right? So I know that this has a solution. I know that f of 0, that says it has one. Is it guaranteed that y equals 0 has a solution? No, it's possible, right? It's possible to do that, but this one is guaranteed. This is not guaranteed. And the fact that this does not have one, this does not have a solution. I know the solution here, that word shouldn't be there. It should be over here. So that should go with this. Sorry about that. And that should go with that. And then this should go with that. So I would say that saying that does not have a solution is not true. Right? Because it could have a solution. Saying that this does have a solution is not guaranteed to be true. Right? Because it might not. It might do that. And we'd never cross it. But this has to have a solution. Because that y value is in between these other two. That's the intermediate value there. But you will not be tested on that. This chapter. It's just if I take it out, then I got to redo the key, and then I got to rescan it and reload it, and it's 30 minutes out. So that's why it's still in there. I don't know, maybe at some point I did include that in this chapter, but I save it for our big theorems chapter where we go through intermediate, mean value theorem, extreme value theorem, all kinds of theorems we'll throw at you. And all of them kind of make sense like this. I think intermediate's kind of, because you're like, oh yeah, in between, inter, the mediates, it's in the median kind of middle. That's 29, jump to 40. Says find the limit as x approaches 3. I plug a 3 in and I get negative 2 over 0. What does this make me think? There's a vertical asymptote. You have to know that right now. Okay, because there's a vertical asymptote, normally, maybe not normally, but a lot of times the vertical asymptote goes in different directions. And that would mean that this would not exist. But what did you learn about if the denominator was squared or had an even power or an absolute value? So that guarantees that when I plug a number really close to 3 on either side, that it still stays positive. And the top, when I plug a number really close to 3 on either side, is still going to be pretty close to negative 2. So this guarantees that the top and the bottom, when I put those numbers together, give me what? A huge negative number. Because any number over a really tiny number is a huge number. Just might be negative, might be positive. So this ends up giving me a huge negative, which would be negative infinity. Because it would look like that. And that saves me the trouble of having to check. Now, if it said 3 from the right or 3 from the left, well, they're both going to be negative infinity as well. And then if you look over here, if I plug a 3 in there, I plug a 3 in, I get a positive 2 on the top, still a 0. But once again, that means VA. This means same direction. But because the squared guarantees positive on the bottom and the top's already going to be positive 2-ish, that's guaranteeing me what? Positive infinity. All right? They're both heading up on either side. All right, so I don't know why I'm doing 40 and 41, but that's 40. And then on 47, okay, so this one, there's a bunch of extra junk in there. Don't let that intimidate you. And also, guys, I cannot warn you enough. Every year I get 1 or 2 people who are really excited about A over B. Every time they see a trig function, oh, but they have the B, they have the B, they have the B, they have the B. And they do it on all the stuff, but guys, the only reason you put A over B is if what? You get 0 over 0 to begin with. And if it fits one of those preconceived rules. And remember, the rules are, if it's a regular trig function of something x over another trig function of something x, and you get 0 over 0. Or it's a regular trig function over just like an x, something x, without a trig function. Or if I flip that. But if you see squareds in there, or cubes in there, or subtraction in there, then you have to find some way to rewrite it so that you can apply those 3 rules. And guys, again, that is only if you get what to start with? 0 over 0. So on this one, I plug a pi over 2 in, and I get pi over 2 over 6. What is pi over 2 over, pi over 2 over 3? What is pi over 2 divided by a 3? Yeah, because to divide by a 3, I multiply by a third, and I get pi over 6. So far I have a sine of pi over 6. And if I plug a pi over 2 in there, what is 2 times a pi over 2 over 3? Pi over 3. So I get a cosine of a pi over 3. Now I got to pull out my unit circle. If you don't know it, it's going to cost you on this test a little bit, and on probably every test we take this year. At pi over 6, what is your sine value? You're right there. It's the y value there, so 1/2 on the top. And at pi over 3, what's your cosine value? 1/2, right? And 1/2 over 1/2 is 1. Right? So don't get cocky and see. A lot of people look at this and they go, oh, when I plug a 0 in there, I get 0, a 0 in there, and I get 1, 0 over 1 is 0. Which is a true statement, except I didn't ask you to plug a 0 in, right? So be careful if I change the value. It's not always going to be zeros, even though a lot of times it is. All right, check it out. What about, it's 29, and that's 40, and that's 47. 56 is right here. This gets people every year if I sneak this on a test. People go, okay, plug a 0 in there. 4 times 0 is 0, tangent of 0 is 0. What? There's no x for you to plug 0 in. It's just tangent of 4. Okay, tangent of 4, whatever the heck that is. And don't go, is it 4 pi? No, it's 4 radians. Now you might have to think about that in a second, but in this case I kind of bailed you out. And then I'll plug a 0 in there and I get a 0. Now, what do I absolutely know about tangent of 4?
You
It is a number. That's about all I know. It is some number. And it might matter whether it's positive or negative, but not in this case. Because what does some number over 0 tell me? VA. And is that squared? And I'm checking from both sides, right? So what do I know? Doesn't exist. Now, what if it was squared? Now, we got to say more about it than D and E. So now we have to think, well, where would tangent of 4 radians be? Hold on. Where's pi? And pi is what? 3.14 radians? So where's 4 radians? Third quadrant. What's tangent in the third quadrant? Positive or negative? Positive, right? Because all students take classes or calculus or whatever. So if I know that it's positive, and the squared guarantees that's positive, if it was squared, I'm like, oh yeah, must be going to infinity there. Has that even shown up on an AP test ever? No. They really take it shockingly easy on you with trig functions. They really do.
Sure.
That doesn't mean college will, though. Yeah.
How many degrees is 1 radian? Like 50 something?
1 radian, I would have to convert.
Okay.
So if I had 1 radian, I could multiply by pi radians over 180 degrees. And I would get 180 over 3.1415. So yeah, probably just shy of 60, 50-ish. 50-ish. So yeah, you're looking at maybe 50-ish, 100-ish. Yeah, not quite there. So 50 there, 50 there, 50 there. Something like that. And then 3.14 is right there. So yeah, but if I know that this is 3.14, and then half of that's 1.57, I can add a 1.57 to that, and that's a 4.71. This is a 1.57, that's a 6.28. You usually can go, oh yeah, 4's in there, 5 would be in there, 5 radians. But again, this is pushing the envelope. Again, I'm not going to try to intentionally slaughter you with every single problem being odd, but don't put an X in there when there's not an X in there. All right, tangent of 4, all I know about it is some number, and if you're really on your game, you know that it's positive, but in this case, you didn't even have to know that because it wasn't squared. All right, and then 61, and that will take care of all of these. 61, I think we kind of talked about this yesterday. If I'm heading to infinity, I have a sine of 1 over x graph. It wouldn't kill you to know that a sine of 1 over x looks something like this. Something like that. If you have a TI-84, it's going to not look like this at all. If you have an Inspire, it's going to look a little like this. But it should be right there at the top, right there at the bottom at -1, +1, -1. It actually goes up and down an infinite number of times in here. But your calculator won't look like that because your calculator, the way it graphs, is it calculates points and then starts connecting the dots. And sometimes the dot isn't all the way down at the bottom when it touches, and then it's going so fast, it's only taking a dot every so many x values. So it doesn't look quite right, but if you had a really nice program that really ran an infinite number of x values, you really see it nicely there. But your TI Inspire and 84 are not those. They are just pretty solid $140, $50 calculators. Which when you consider that's cheaper than a pair of J's, pretty good. You know what I mean? To be able to carry around and take a beating and still work for you. But you can do this, even though we don't know the graph, because if I knew the graph, I'd go, oh, the limit to infinity must be 0. The limit to negative infinity must be 0. But if you think about it, you can get it too. If I plug an infinity in there, what's 1 over infinity? It's approaching a really small number, right? Close to 0. And then what is sine of something really close to 0? Well, then if you know the sine curve, what's the sine curve as you're approaching 0? 0. Which is true about the limit to infinity as well. All right? And what if I said x goes to 0? Well, Well, 1 over 0 is what? And again, you could say D and E, but careful, because it's really not 0, it's really close to 0. So what's 1 over a really tiny number? Either huge, if you're coming in from the positive 0, or negative huge, if you're coming in from the negative 0. So infinity or negative infinity? What's the sine curve as you go to infinity? That's true, but what y value am I approaching? I'm not. The definition of a limit is the y value that I'm approaching. I am not approaching a y value. So the limit out there is d and e, and the limit that way is d and e. So if I said 0, it would be a d and e, which makes sense on this graph too. What's happening as I go to 0? It's not defined there, because it's oscillating an infinite number of times. But most people don't know this graph, because they're not, I don't know, maybe taught by curious people that bother to graph all little things when I'm just wondering what the heck and why. But anyway, whatever. Or maybe you're not curious. Anybody else on this thing before we move on to something else? Okay, so review number 2, unless you have a question on the quiz number 1. Anybody? Everybody find the quiz and everything okay? No issues with my Schoology management? All right, here's review number 2. It's on page 63. And I'm not going to go through every one. I am literally just going to eyeball this and see. And I'm just going to throw stuff out at you. What about number 2? Give me some ways you could do number 2. The top is bigger than the bottom, so the top is clearly growing at a greater rate than the bottom is. So it should be going to infinity or negative infinity, but I don't know which one. So give me a way I could figure that out.
Even power, 70 possible.
The top part would, but and you may be able to think your way through that, but the bottom part may or may not be even. Okay, if I were to divide, what would happen if I divided a positive 4x squared into a 6x to the 4th? That goes in there, end up with the what? The 3/2 x squared term, and my asymptote would look kind of like that. Now, what would that look like if it was an asymptote? An upward opening parabola, right? So what should the limit be as I head to the negative infinity? Positive infinity. That's one way to do it. That's actually not the way I taught my students last year, but that is one way to do it. And that's going to bail you out all the time if you understand behavior of polynomials. You basically look at the asymptote, which is what its behavior is doing to infinity, and you can tell about what the graph's doing. I told y'all to do this. I think I talked about, y'all remember me saying, hey, what if I gave, what if I let this be Iona's money function? No, this right here. And I said, what if I plugged 1,000 in, which is like a 10 cubed? A 10 cubed to the 4th would be a 10 to the 12th times 6. Okay, so this is billion. This is Bezos. So $6 trillion, Iona, set for life, right? She's sitting back there. She's contemplating just bailing right now, moving on to retirement. But then, I don't know, say Sarah Parker goes, oh, I mean, you've got all this money. This is Sarah Parker's money function. I plug 1,000 in there. She goes, Iona, help a sister out. Can I just have 2,000? Well, Iona's pretty gracious, pretty nice. She might be like, sure, enjoy your time. Okay? I may toss her that. All right? And let's just say this is Ackerman's money function. $3. Is this going to have any dent on Iona? So to infinity, this is relatively nothing, isn't it? So basically, this lead factor as well as that lead factor, even though that might be a big number, if I plug 1,000 in there, we're talking about 4 million minus 10,000. If I got 4 million in the bank and I got to put a new air conditioner in there, I'm not going to go home in tears, right? If I'm out 10 grand, because I'm still sitting on $3,990,000. I'm okay, right? And I'll probably outlive my air conditioner. Hopefully. Anyway, so the point is, these two are driving your math. And if I think, well, if I plugged a huge negative in there and raised it to the fourth, it would be a huge positive. A huge positive times 6 is a huge infinity. If I plug a huge negative in there and square it, it becomes positive. A positive times 4 is a less huge positive infinity. Well, what is a bigger positive infinity over a smaller positive infinity? A positive infinity, because the top's growing faster. If the bigger power is on the bottom, then this wouldn't even been a point, would it? It's bigger on the bottom's growing faster, it's always 0, but we already know that with limits to infinity. But you do need to check to see about the sign, because if this had been cubed, that would have been a huge negative infinity over a less huge positive, it would have ended up being a negative infinity. But it's not, so positive infinity. But you can think in terms of asymptotes all day long. Divide the bottom into the top, look at the power in the lead coefficient sign, and think about what that's doing. So if I ended up with like a negative x cubed, oh, to the right infinity, to the left negative infinity. You can always think that way. How about 6? What do you get?
You multiply by x plus 3 times
Whoa, 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 whoa. Why are you doing that?
because
You got
0 over 0.
0 over 0. And because you don't just look at, like, if I change that to x equals 1, I get an answer. So don't just look at these word fractions and go, oh, I need to multiply. I think you did it right, but yeah, plug the 0 in. You get 0 on the top and 0 on the bottom. Okay, so what's my rule? Multiply the top and the bottom by what?
X times x plus 3.
Careful. And I don't think it's going to hurt you multiplying by an extra factor, but all you have to multiply by is the common denominator of everything. So if you think about all of these as fractions, what's your common denominator? X plus 3. What you're going to end up with is just an extra x you got to cancel. But if you just do the x plus 3, the math will probably be a little cleaner for you. I mean, if you need to do an x, do it, but you didn't have to here. So when you distribute that, the x plus 3's cancel and I get a 6. Right here, I get negative 2 times that, which ends up being negative 2x minus 6. And on the bottom, I get x and x plus 3. And then you can see the 6's cancel. 6 and the negative 6 cancel. And then the x's cancel. And I get a simplified value that I can easily plug in and solve for. And essentially, what was I doing here? I was rewriting this problem so it had a what? So I could see where the hole was. Right? Remember how holes, you get 0 over 0, you cancel the common factor? That's essentially what I was doing. Look, there's my hole. And I can cancel it now. And I gave you a hint on these, never to FOIL the bottom out or distribute the bottom out, because if you do, it's going to be less easy to see what actually cancels. Maybe not for some of you, but for some it will be. What about 10 and 11? If I get 1 over 0, what does that mean? Or any number over 0. Vertical asymptote. What do you do with VAs? Check both sides, or use maybe some of my tricks that I had. What happens when I get a 0 over 0? I have a hole. Why do I say most likely? Do you remember the one that it looked like a hole initially? Like, check out this limit. Plug a 3 in. 9 minus 9 minus 2. 0. What's that look like? Wait, that's not what I wanted to do. Hold on. This is what I wanted to do. Sorry. 9 minus 6 minus 3. 0 over 0. If right now you go, oh, there's a hole. You spoke prematurely. Watch. When there's a hole, I factor. Right? Cancel the common factor. And then redo the limit. But wait, what do I get when I redo the limit? 4 over 0. So now what does that mean? There's a VA. That occasionally happens. That's why I said when you're calculating limit, you get 0, 0, what would the graph look like here? Most likely. Well, most likely it is a hole. But occasionally this happens. I have, on many occasions, I have given a test that says, hey, what would this graph look like as you approach 3? And half the class goes, hole, because you get 0, 0. But if you went one step further, you cancel and go, oh, wait, vertical asymptote. And if you end up with a VA, it kind of trumps the hole. Basically, that hole didn't even exist. Now, it's rare that that happens. I really have to engineer the problem for it to happen, but I have done that in the past, for sure. So be aware of that if I'd ever ask that question, which a lot of times I don't. I just say, find a limit. And if I said find the limit, you would have probably gone through this process and then gone, oh, so now what happened? This is where people could still go wrong on this. What does that mean? VA? But what do I use to determine the limit? This x minus 3 or that x minus 3 squared? Because if it's squared, I'm probably going to say infinity. But if it's not squared, I'm going to say d and e. So what do I use? I canceled that 3 out. I'm basing this on this, aren't I? So don't look back at the original and look at that and go, wait, this thing's going in different directions. From the positive side, it's positive, but from the negative side, it's negative. This is d and e. Y'all with me? So be careful on stuff like that. That's a curveball I've thrown in the past, just to see who's really on their game. Separate the wheat from the chaff, right? If I talked to y'all about that analogy?
No.
My new students, no? Okay, so in the olden days, they would harvest the wheat, and then, you know, wheat has like a kernel and it's got a lot of crud on it. You don't want to have all that crud in your bread, right? So you throw it down on the stone floor and you bring in the oxen, and they just walk around, they eat a little bit, they stomp on it, and it separates the husky junk from the wheat. Now it's still a mess on the floor, right? So they wait for the breeze to come in and they throw it up in the air, they like get shovels, and then the wind blows the husky junk or the chaff away, letting the wheat fall down, and you separate the wheat from the chaff. Well, I don't think any of y'all are chaff, but I do put problems on there to see who really, really, really is awesome and who is a little flaky and might just blow away with pain and suffering. Anyway, so occasionally I'll do that, and the amusing part of that was that when I first told that story, it was back in this kid, you remember Hamilton Simpson? I've talked to you about him? Like 2001, anybody know the new volleyball coach? Y'all know her?
My sister does.
I taught her back in 2001. Anyway, there was a kid in there, I think it was that year, he came in and he was like, man, I'm chaff. I was like, dude, what are you doing? He's like, chaff. And I was like, chaff? And he goes, yeah, I'm not weak, I'm chaff. And I'm like, dude, it's wheat. He goes, oh. Anyway, we want to be wheat in here, not chaff. So sometimes I'm going to push the envelope just to separate, put some separation in the grades. Hopefully not, but occasionally I will. What about I don't know. What about 13? 13. 6 from the left. Well, ignore that now. We just want to see what happens there. So I'm just plugging a 6 in. 36 minus 12 is 24. Minus another 7 is 17 over 0. So what's happening here? There's vertical asymptote. Now normally, like I would in number 12, same problem with not left or right, I would just say D and E, right? Because I know it's going different directions. But this is just from the left. So it's going either up or down. So my answer is going to be either that or that. It's just which one. And this is the time you actually have to physically check. So I'm going to say, well, I don't know which way. So 6 from the left means like a 5.9-ish. If I plug the 5.9 on the top, what am I still going to get? Really close to 17. But a 5.9 on the bottom, although it's really close to 0, it now is what? Negative close to 0. The top, really close to 17, is still positive either way, whether it's on either side. But either side of this makes a difference. So what's this thing doing? It's going to negative infinity. What about 17? Oh yeah, I love these, man. A over B, baby. 3 halves. Ugh. Don't get happy on that. What's your goal? I mean, what do you do on these? Plug it in. And if I plug a pi in, what do I get on the top? 3 pi, 3.68-ish, whatever, that means positive. All right, I'm not taking a tangent of it or something. It's just the number 3 pi. And the bottom, what's tangent of 2 pi? 2 pi is right back to where 0 was. So what's the tangent of that? So I end up with a positive number of 0. What happens here? A VA? But is anything squared? Must be different directions, must be DV. And honestly, on the AP test, on trig, they usually don't even have infinity answers. In my experience, in my memory, you see the infinity and the negative infinity a lot on polynomials and rational functions, but when they get to this, it's more like, D&E. So even though the answer might be infinity, if you don't see infinity as an option, and D&E is an option, wouldn't you go with D&E? Since infinity literally means does not exist, and it's going up or down or whatever. So in the absence of a multiple choice that has infinity as an option or negative infinity, you'd have to go with that, because it means the same thing in part. Remember these? 18, find a value which would make it continuous. Let's think about that. This is a piecewise function. Now for a piecewise function to be continuous, what has to happen with the two parts? They've got to what? Join at this value, and they have to be continuous not at that value. Well, what is that? And remember, A is a constant. So that's a line. What's this? 1/4 x plus 5 halves. Another line. So I've got 2 lines coming together. I just got to make sure that not only that the value exists, that there's a point right there, but that the 2 lines come together. That's checking continuity. Does the value exist? Does the limit exist? Are they equal? Well, does the value exist at 2? Yeah, because, and what would it be if you plug the 2 in? 6a minus 9. So the value of f of 2 is 6a minus 9. All right, does the limit exist? Well, from the left you'd get 6a minus 9. From the right you'd get 12 over 4 is 3. So the limit would exist when 6a minus 9 equaled what? 3, which would be when a is 2. So when a is 2, the limit exists. And if I plug a 2 in there, what? The value would exist. Well, I just got to make sure that that's all equal. Well, I think it does. Because if I plug a 2 in there for a, this would be a 6x minus 9, right? And look, the limit would give me 3. I'm sorry, the value would give me 3. The limit from both sides is 3. And if the limit is 3 and the value is 3, they're equal because it's 3 equals 3, then at a equals 2, it'd be continuous. So basically all I'm doing there is taking the limit in the left from the right and solving, and the limit from the left and the value at that point are usually equal. So I guess you could say all 3 parts must be equal, but because those are the same, you're really just solving for 2 of them. Yeah?
That seems pretty easy. Is there any anything tricky that can happen with that?
Not with this typically, but later on, they'll change this word to differentiable. And basically what that means, differentiable means not only is it continuous, it connects, but differentiable means the derivatives or the slopes would have to be the same. So so something like this that connected, even though it's continuous, doesn't have the same slope. But something like this parabola and this sine curve would connect smoothly. So you would actually have to do this extra step and find the derivative function and make sure that the slope right here and the slope right here were the same.
Did we do that last week?
We probably did, when we got to derivatives.
Yeah.
So this tends to look really simple in hindsight once you do the derivative stuff. And it's really not that bad even now, but this actually gets asked on the AP test, but probably less frequently than the whole differentiable question, because the differential employs 2 parts. Why would they do 1 part when they could do 2 parts, right? All right, look at the similarity to this line, 19 through 22. Look at that. All 4 of these are different. Right here, plug in a 0, 0 over 0, that's a rule, 6/3 equals 2. But what happens here? 0 over 3. What's 0 over 3? 0. Merry Christmas. What happens here? Sine of 6 over 0. Now, sine of 6 over 0 means a number, I don't know what it is, right? I know it's close to 6.28, so it's down there in the 4th quadrant. So it's some negative number, but I don't even need to know that, right? Because as long as I know that I have a number over 0, what's happening? VA, not squared. I'm checking from both sides, DNA. But what about that guy?
You're only checking from one side.
And I have a number over 0. I know there's a VA, but I'm only checking from the left. Now from the left, like negative something, what would the bottom be? Negative. What's the top? We'll check out the unit circle. 2 pi is 6.28, which means 6 is somewhere right there, isn't it? What would sine of 6 be then? Sine's positive in the first and second, but negative in the third and fourth. So I end up with a negative over a negative. So from the left, what's happening? Oh no. Not an AP question. But not only am I trying to get you ready for AP, I have many students who make 4s and 5s on my test and go, man, you know, I'm joining a sorority or fraternity. I want to have an easy fall semester. I'm going to take Cal 1 for an easy A. And most of them get A's. Because even though the Cal 1 is not as easy as you might think, because in college they make you show some of the proof stuff. They get bogged down in a lot of that. So, whatever. But they make you think through some of this stuff more mathematically than some of the graphical approaches we take in this class.
What?
All right?
23. Is that 1?
Yeah, and Akram, I've been quoting you. I love the way you talked about this. I'll keep talking if y'all want to go, but right here, if I'm coming in from the right side, Gracie, of 4, remember, from the right side of an absolute value, you use the x minus 4 part. If I'm coming in from the left side, I use the negative. So because this is a regular x minus 4, I can cancel these and I just get 1. But if I was coming in from the left, like right here, then I'm going to use the negative of the x minus 4. And now when I cancel, I get a negative 1.
Thank you.
Yep.
Yeah, your thumb's here.
Yeah.